So the problem we're trying to solve here at SAIF Systems is the inherent distrust of autonomy in vehicles particularly, whether that be air, land, sea or space. When you have an untrusted input that goes to a vehicle controller, there is no way, if you're using something like a non-deterministic method like AI, to assure that that vehicle will perform the way you want it to. It won't break a rule set, it won't break the rules of the operating domain. We're setting out to physically solve that problem for the world, allowing trusted autonomy to be used.
Yeah, so our solution keeps autonomous vehicles safe in operation by monitoring the system in use, using an onboard digital twin or mathematical model of that system. And we assess against constraints. So those constraints can be the rules of the air for a drone, for a vehicle, it might be the highway code, for example. And if we predict a violation of those constraints, our software steps in and takes a verifiably safe corrective action, keeping the system not only safe, but operational. So moving beyond simple safety behaviors like emergency stops or for drones returning to home, we can fail safe and fail operational so that we can move beyond small scale test or research deployments of these autonomous systems and actually operationalize autonomous vehicles and autonomous systems everywhere in our lives.
We run in real time at the edge, physically on board the platform, the vehicle, the system itself. And we don't require any human in the loop for those safety features to work. But the real enabling feature here is that you don't require data link, you don't require comms. This can run there and enforce those safeguards for you 24 hours a day, 365 days a year, and keep that platform on task, on mission, wherever possible, or worst case, entirely safe, without or anyone else having to physically press a button or take that action to do it. And when you go beyond the kind of remote working on Earth, we look into the drone space. Again, you want to deploy drones over a long range where you can't guarantee the communications, the GPS, because of jamming and other interference in the world now. We can enable those to go 1,000, 2,000 miles and prove that they will be safe and carry on with their mission, whether that's delivering products to somebody on a remote island, medical supplies, or whether it's in a military context. We can do all of those things and guarantee those safeties to the same kind of level of safety that you see when you get on board a commercial airliner.
One of the aspects that our software provides is that explainability. Our software is deterministic. We are purely enforcing constraints on the system in operation. And those constraints are understandable to us as human beings. You can boil them down to things like distances, positions, speeds. So every time our software steps in and takes a corrective action, it's to do one of those things. It's to keep the system in the right position, keep it conducting actions that are permitted, or operating within certain boundaries of the system itself. So when we take that corrective action and somebody wants to look at those log files and the telemetry and the sensor feeds, we can understand exactly what happened at that point in time and use that to make the systems better in the future, make it safer as we go forward. And that's what our software does, and that's how it helps address that explainability problem with AI.
So we're here today testing the UGV through several scenarios in the off-road proving ground. And what we're trying to achieve here is prove out the data in our algorithm, the safeguards that we place around these vehicles, ultimately ensuring mission success. The Myra testing site is really unique for us because you have every surface we could possibly want. So looking at UGVs for autonomous mining use cases on Earth, you have the kind of representative environments around you here that you can't get really anywhere else. But also looking at taking this off-world, which is our ambition in the future, we have some areas which are representative of lunar style surfaces with loose dirt, gravel, high inclines, things like that. So we can actually test in those kind of environments now, looking ahead for that future development. We've taken this algorithm from aerospace, from air, and actually applying it to ground vehicles. And that's been really useful because you can't do this really anywhere else with the kind of telemetry that you can get from the Myra team as well. Actually looking at that data very, very deeply into the algorithm, into the system's performance. That's a really unique opportunity for us that has actually helped us and provided us to do here with Myra. And it's something a company at our stage would not have been doing probably for another few years. And I think that's been a really unique experience for us and really valuable data out of this testing. Well, I think being a participant in the CAM Scale-Up UK programs is really important long-term for us because one is the alumni network, but also the relationships you build with regulators, with OEMs, and the physical data that we're going to get from the testing at the test site, and the effectively the academic support for that, saying that the system works, saying that the data is correct, saying that the data sets are valid, is just crucial for us when we present this to potential customers, and also when we raise future investment, which is inevitable for a company like ours. Yeah, so there's a few different domains that our technology can be applied to in the future. The on and off-road autonomous vehicle domain, but aerospace is probably the biggest market for us in the next 5 years, certainly as we develop the kind of more difficult, weirdly, on-road and off-road space. Whether that be UAVs or space systems, and then taking that into the maritime autonomy domain for both subsurface and on-surface shipping and vessels.
The thing that really excites me is where this leads. So I think both myself and Kyle, we've seen some incredible capabilities, some incredible autonomous vehicles on the road, maritime autonomy, drones, and I'm always left wondering why we don't see more of them in our everyday life. And this problem of assurance is absolutely critical to that. You know, the reason we don't have drone deliveries to your doorstep is because of safety, it's because of assurance. And actually our technology helps unlock that, unlock the operationalization of all of these systems across domains, across industries, and that's exciting. That's really, really exciting to be part of the solution and actually seeing these systems everywhere in our daily lives.